This line introduces the core concept of the problem. Understanding the L1 underscore ratio hyperparameter within the ElasticNetCV algorithm. ElasticNetCV is a machine learning tool used for linear regression. It's a clever combination of two other regression methods, lasso and ridge. L1 underscore ratio is the key to controlling how much of each method is used in the blend. This line indicates that you'll be answering a multiple choice question that tests your understanding of L1 underscore ratio Get ready to put your knowledge to the test. I'm presenting a multiple choice question about the impact of the L1 underscore ratio parameter on the performance of ElasticNet regression. You need to identify all the correct statements among the options provided. This is a great opportunity to test your understanding of this machine learning concept. This option tests whether you understand that setting L1 underscore ratio to 0 uses only the ridge regression part of the ElasticNet model. Think of it as a slider. At 0, you're all the way to the ridge side. Here, I want to know if you know what happens when the L1 underscore ratio slider is set to 1. That's all lasso. This assesses your understanding of ElasticNetCV S cross-validation feature. ElasticNetCV cleverly tries many different combinations of L1 underscore ratio and alpha the overall strength of regularization, to find the best settings for your specific data. Pretty smart, right? This question checks if you know the effect of the L1 underscore ratio on the final model's complexity. Increasing L1 underscore ratio moving more towards lasso, results in fewer variables being considered important in your model. A sparser solution. This simply marks the end of the question section. Let's see how you did. Good luck. I'm focusing on the L1 underscore ratio hyperparameter within the ElasticNet regression model, a key part of ElasticNetCV from Sklearn. This parameter controls how much we blend L1, lasso, and L2, ridge, regularization. I'm evaluating 4 statements to see which correctly describe how L1 underscore ratio works in ElasticNet regression and ElasticNetCV Setting L1 underscore ratio to 0 means I'm using only L2 regularization, which is exactly what defines ridge regression. A L1 underscore ratio of 1 means I'm using only L1 regularization. That's the defining characteristic of lasso regression. The magic of ElasticNetCV lies in its automatic cross-validation. I'm finding the optimal combination of L1 underscore ratio and alpha which controls the overall strength of regularization, through this process. As I increase L1 underscore ratio I'm increasing the lasso component's influence. Lasso is known for shrinking many coefficients to exactly 0, leading to a sparser model. That means fewer features are considered important in the model. This instruction means I need to pick all the statements that are true, not just one. I'm assessing your understanding of the L1 underscore ratio hyperparameter within the ElasticNetCV model. This hyperparameter controls the balance between L1, lasso, and L2, ridge, regularization in the model. We'll examine several statements about its behavior. This statement is correct. When L1 underscore ratio is 0, only L2 regularization is applied, resulting in a pure ridge regression. Think of it as only using the ridge penalty. This is also true. Setting L1 underscore ratio to 1 means only the L1 penalty, lasso, influences the model. It's like only using the lasso penalty. That's right. ElasticNetCV cleverly uses cross-validation to find the best combination of L1 underscore ratio the mix of L1 and L2 penalties, and alpha the overall strength of the penalties. This automated process helps you avoid manually tuning these hyperparameters. Absolutely. As you increase L1 underscore ratio you are increasing the lasso component's influence, which is famous for producing sparse models. meaning many of the model's coefficients become zero. This is because lasso aggressively shrinks less important coefficients to exactly zero. This is the core topic of the quiz. Understanding the role of the L1 ratio parameter in the ElasticNetCV model, a type of linear regression model. I'm focusing on the L1 ratio hyperparameter within the ElasticNetCV function. It's a key setting that blends two types of regularization. Let's tackle this multiple choice question. It's all about understanding how L1 ratio influences model behavior. I will evaluate each statement to see if it correctly describes the behavior of the L1 ratio parameter in ElasticNetCV . When L1 ratio equals 0, only ridge regularization is applied. Therefore, it is correct. When L1 ratio equals 1, only lasso regularization is active. This means only L1 regularization, lasso, is applied. Therefore, statement B is correct. Yes. ElasticNetCV is designed to automatically find the best settings for L1 ratio and alpha using cross-validation, making option C true. Increasing L1 ratio shifts the model towards lasso regularization. Lasso is known for shrinking some coefficients down to exactly 0, producing a sparser model. Thus, statement D is correct. This section encompasses the entire multiple choice problem and the analysis of the correct and incorrect options, which I have already discussed above. This refers to the parameter in the ElasticNetCV model from Sklearn. I use this parameter to control the balance between lasso and ridge regression within the ElasticNet model. Think of it as a mixing knob. This question tests your understanding of how the affects the ElasticNet regression, specifically relating it to lasso and ridge regression. I'm basically asking you to check which statements accurately describe the effect of changing the value. When I set to 0, I'm telling the ElasticNet to only use the L2 penalty, ridge regression. This is true. If I set to 1, the ElasticNet uses only the L1 penalty, lasso regression. This is also true. The ElasticNetCV model does cross-validation for you automatically. It finds the best combination of and alpha, regularization strength. That's correct. Increases the impact of lasso regularization. Lasso is known for making some model coefficients 0. Sparse solutions. So this is true. This indicates whether the corresponding statement is true or false in the context of the hyperparameter. Same as above. Same as above. Same as above. I see that's the focus of the quiz, the hyperparameter in ElasticNetCV. It's a crucial tuning knob that controls the balance between two types of regularization. This is the core question. We'll evaluate each statement based on our understanding of an ElasticNet. I'll explain. A of 0 means we're using only ridge regression's penalty. It's like saying we're completely ignoring lasso's effect. Here, A of 1 means we're exclusively using lasso regression's penalty. It's the opposite of the previous case, pure lasso. As we increase, we're increasing the influence of lasso. Lasso is known for creating sparse models, which means many of the model's coefficients will be 0. This helps in feature selection. ElasticNetCV is clever. It does cross-validation automatically to find the best and alpha. ALPHA is another hyperparameter that controls the overall amount of regularization.